This week on Cloud S.L.A.W, we're going to learn about a cool thing called a VPC endpoint. In our last lab, we set up a VPC, launched an instance into a private subnet, and then logged into that instance using the web console with a tool called Session Manager. I mentioned in that post that the way Session Manager works is that there's this little software agent pre-installed into the instance, and it's constantly trying to connect with the service. It's polling and checking with the service to see if there's a connection request. If there is, and if all the permissions line up, the little terminal window opens up in your browser. I raced past a lot of the networking in that last lab, but this week we're going to learn why that private subnet, it wasn't totally private. And we're going to learn about a cool capability known as a VPC endpoint to kind of bend reality like a warp drive. Let's talk about how we use NAT gateways to connect to AWS services like Session Manager, which is what we did in that lab. In that instance lab, our CloudFormation template configured a NAT gateway for our private subnet. As a reminder, this allowed outbound internet access from resources in that subnet, but no inbound access. Then our instance was in a security group that blocked all that inbound access, but allowed any outbound access. Let's look at it on the whiteboard and kind of walk through what we did. For Session Manager to work, our instance connects through the Session Manager API endpoint, which is sitting out here. Whoops, let's get into drawing mode, which is sitting out here on the internet. Now, an API endpoint is the destination on the internet for API calls. And since AWS is a public cloud platform, it means everything that it offers is available on the internet for anybody with a big enough credit card. So all the API endpoints for all the AWS services are all out there and are internet accessible. Even when you use the web console, you're still making those API calls. Our lab worked because the traffic was routed out through the NAT gateway onto the internet and to the Session Manager API. So we made the API call from the instance to the NAT gateway that routed it through the internet gateway. Remember, you need that to connect to the internet and to the Session Manager endpoint. So technically, the traffic is actually exposed and out on the internet here. And technically also the service we connected to, which is Systems Manager, because Session Manager is part of that. Now, that's great, but sometimes you don't want to ever allow your resources to access the internet, especially if you deal with pesky compliance auditors. In those cases, we can use something known as a VPC endpoint. VPC endpoints, I made a joke about the compliance auditor, and there's a lot of good reasons you might really want a private subnet. Because if your resource can't talk to the internet, it makes it a lot harder for an attacker to do anything nefarious, even if they get access. Take the example of crypto mining. Even if the attacker got you to run the mining software, it won't work if it can't talk to the internet. But as you saw in the diagram, with a fully private subnet, one without a NAT connection or any other connection to the internet, you would not be able to talk to any AWS services. And that's why we had to use that NAT gateway. Now, AWS fixed this for a fee with something known as VPC endpoints, which are generically called service endpoints if you're looking at other cloud providers. It's like sticking a private network connection on your subnet, and it routes the traffic inside of AWS, and it is limited to within the same region, but that traffic never touches the internet itself. And that's way that we can talk to Amazon's API endpoints without requiring a NAT gateway or other access to the internet. And heck, using a capability called Private Link that we'll get to later, you can even publish your own services and access those through these VPC endpoints. Now, there's two kinds of VPC endpoints, and we're going to use one of those today. Interface endpoints put an elastic network interface into your subnet, and any traffic routed to that network interface will be routed on the back end through Amazon's network directly to the API endpoint for that service without ever touching the internet itself. And that ENI has an IP address, and you'll see that when we go ahead and set it up. The other kind is a gateway endpoint. They do their magic right within the route tables and with domain name server stuff, and they're very, very cool. but they only support Amazon S3 and Dynamo database. So it's this route table magic stuff that Amazon realized wasn't going to scale to all of their other services. So most of what we use will be interface endpoints, but you can use those gateway endpoints if you want to magically connect to S3 or to Dynamo database. Let's go back over to the whiteboard and see what it looks like. So here's where we originally started with our traffic, running through from the instance to the NAT gateway out to the internet to get to Session Manager. But here's what it looks like when we're using a VPC endpoint. The traffic from the instance is routed to the VPC endpoint, which has its own IP address. And then that has kind of like a private little tunnel. And honestly, it's a software defined network. I don't know exactly how Amazon implements this, although I could make some guesses, and then routes it to the Session Manager service, which is still existing within the same region in AWS. But you'll notice that at no point does anything touch the internet. That's why these VPC endpoints are so cool, because it's going to route that traffic. We don't have to touch the internet, and we can now have these fully private subnets. We don't have to use any of our NAT gateways. You might ask yourself, now, how does Session Manager even know where to route that traffic? Because if you think about it, we have to route it to that IP address on that network interface when you're making an API call to, I don't know, ssm.amazonaws.com. Well, does it through magic. More magic. No, it's not magic. By default, when we configure this, you'll see this in the lab. If you are using the Amazon provided domain name server built into the VPC, which is what we use most of the time, it will automatically update for us so that when you go to call that service, it's going to know to route it to that IP address in your subnet as opposed to routing it out to the internet at large. So when you go to ssm.amazonaws.com, it's going to route it now to that endpoint. It's not going to route it to wherever ssm.amazonaws.com exists on the internet. Now, service endpoints, they are not free. They cost a penny per hour and a penny for the first petabyte of data. This can be cheaper than a NAT gateway, but it certainly is, definitely not going to be free. Depends on how much traffic that you're moving around. And remember that these VPC endpoints are specific to a service. The one we're going to build is just for SSM, which enables Session Manager and some other things. But if you want to connect to S3, that would be a different one, and Dynamo would be a different one, and SQS and SNS and all these other services, you would have to add multiple service endpoints. And so those charges would add up because now you're going to be paying that penny per hour for every one of those services. Today, we're going to skip through some of the nuance and the complexity, but just to show you real quick, let's switch over. There's actually a diagram that shows how you can set these up for load balancing, and let me zoom in a little bit here so you can see that a little bit better. So where you might have multiple endpoints and the traffic can be routed across multiple availability zones, just giving you an example, and this one is connecting to the CloudWatch service. All right, so what are the key points? How do we tie all this together? All AWS services have API endpoints. That's so people can connect to those services over the internet. This means that even private subnets need internet access to talk to the AWS services, as if, say, you have an instance that wants to pull data out of Amazon S3. VPC endpoints create private connections to those AWS services so that you don't have to allow any internet access from your subnets. The kind that we're going to use today are interface endpoints, and those are used for everything except for S3 and Dynamo. And the way they work is they create a special elastic network interface in your subnet, just like your instance has an ENI. Everything that is connecting to a VPC has an ENI. And then you reroute your traffic to that ENI, and it will go to that service. And it's all done automatically if you're using the default domain name service that's built into VPCs. The network interface will then connect directly to the AWS service. This does only work in the same region to keep your traffic private and off of the internet. Now, if you actually use your own DNS, you would have to go through and change the entries to point to your own, those different IP addresses that are associated with those service endpoints. Okay, let's go jump into the lab, and we're actually going to build this and test it. In this lab, we're going to use a CloudFormation template that I set up that's going to create a VPC for us. No NAT gateway this time. There's going to actually be no access to the internet from our subnet. And I also went ahead and modified this one to launch an instance, as well as create all the security groups and other stuff that we're going to need. So let's go ahead and we're going to dive in. We're going to start by deploying that template. Then we're going to create our VPC service endpoints. We will need 3 endpoints to make this lab function properly. So within the console, as we've been doing recently, let's go to test account 1 and administrator access. Then let's go right to CloudFormation. I've got mine on the pick list here because I was testing some stuff, but you might need to type it up there. And oh no, we're up to maybe 24 cents in costs this month. I try my best to keep it close to free. Can't keep it free. And let's create stack. Choose an existing template, Amazon S3, and paste in the template from the blog post. I'm gonna go grab that. All right, copied it out, paste it in there, and click next. Then let's call it S.L.A.W because I like my free advertising. Click next. Scroll down, and I'm going through this quickly. We've done it like half a dozen times so far. Don't forget, you got to click that little blue box there at the bottom and then click submit. And it's going to start spinning up. This will take about 3 to 5 minutes because it needs to go ahead and actually run that instance. I will go ahead and pause while this is creating all of our resources. And you can hit refresh and watch it in progress. That took about 3 minutes for the creation to be complete. All right, let's jump into the meat of the lab. So let's go to VPC. And you'll see that I built out a VPC that looks very similar to the one we did before. We'll go to Your VPCs, click the Cloud S.L.A.W checkbox, pick that up a little bit and hit that resource map. And you can see that we have our public subnets routing out through an internet gateway, but our private subnets, well, they just go to a private route table. And if I click on that and look at that route table, you can see that the only route is local traffic, local. So there's no route to the internet. So anything I deploy there is completely safe and completely isolated from the internet. Well, we have an instance running. I'm not going to go ahead and show that, but let's go create our actual VPC endpoint. And we're going to need 3 of these, and I'll explain why in a moment. So click on Endpoints, and there's no endpoints. So we're going to go ahead and click Create Endpoint. And we're going to name these for SSM. We're going to call it SSM-1, and then we'll get to the other ones in a minute. Now, in terms of the services, the first one we want to do is type in that SSM into the search box and pick the top list. So it's going to be the .ssm service. Then scroll down. You have to hit this checkbox to actually select it. Remember, that's just a search filter. So now I've picked that we're going to do our interface VPC endpoint, and we have to put it in a VPC. It's easy. We only have the one. And you'll notice if I click down on the additional settings, it's already automatically doing the enabled DNS name for us. So this is that magic bit. It's just going to make our lives easier. You would actually have to do a little bit more if you're doing this through CloudFormation or through API calls, but this will set it up for us so that if we go to connect to the SSM service, it will automatically know what network interface which VPC endpoint's been created. We'll do this in US West 2A for our availability zone, and then click on the down arrow, and we want to put it in our private subnet. So S.L.A.W private 1. You notice it pulls up the ID, but you can read it right there, which makes our life a little bit easier. Let me just double check I clicked the right one. There we go. Now we have to give it a security group name, or we have to associate a security group. And the one we're going to use is the S.L.A.W security group, not the private security group, and look for the one that says it allows HTTPS traffic. This is going to allow port 443 traffic. Remember, anything on a VPC, all resources have to have an associated security group with them. And that includes endpoints, particularly if because they're ENIs, Elastic Network Interfaces that have an IP address. So it has to have a security group. This security group allows all outbound access and allows connections over HTTPS, which is the protocol that's used for all the API calls. Okay. Scrolling down, don't worry about a policy. That's actually a very cool kind of capability we'll do in a future lab. Scroll all the way down, and then hit create endpoint. Now it's being created. You can see that it's pending. So let's create our next one. This is because SSM has three kind of different things that it needs to be connected to. We'll call it SSM2. And if I search on SSM and then type another M for messages, and this is what allows some of the communications that we need. So I'm going to hit that checkbox. So it's the SSM messages is going to be that service. And the rest is the same. Same VPC, the same availability zone. And remember that diagram, you can create multiple resilient ones, but we're just keeping it easy. You don't need to designate an IP address. It's just going to automatically pick one for us, which is fine for the lab we're doing. And then we want that S.L.A.W security group for the endpoint. No policy. And then click create endpoint. And we have one more to create. So let's go create endpoint. We're going to go SSM-3. And this one's a little bit different. Type in. Took about a minute for that to pop up. I'm just hitting that refresh button and they are all available. Okay, so we are all set here. And let's go over to the EC2 service to try to connect. And we have one instance running in our environment. So go ahead and click on that. Click the little checkbox. And again, you notice no public IP address. It's running in our private subnet. And you could validate all of that by looking down here, S.L.A.W private 1. So there's no route to the internet or from the internet to this instance. And yet, we're going to go ahead and click connect. Notice all these errors because everything is locked down. Let's go see how Session Manager is doing. Okay, so the agent is listed as offline, and this does happen frequently because we're moving so quickly. I'll try and hit a refresh on this page, but I think what we're going to do instead is a little trick. So click on the instance, and then we're going to go to instance state and click reboot instance. What this is going to do, it's going to flush the DNS. Remember that agent's been trying to connect, so it might have that IP address cached locally. And this is an important skill to know about. And I'll hit refresh reboot. And let's go with reboot. And it started rebooting that instance. This is another case where we'll go ahead and I'm going to pause and I'm just going to look at the clock and give this, I don't know, 2-3 minutes, and then we'll come back to it, just giving it time to reboot. It should have been rebooted by now, so let me go ahead and click connect again. And Session Manager is still trying to connect, and it's okay. We'll just give this a little bit of time. So I'm going to hit pause, and behind the scenes, I'll be refreshing the page every minute or two, and it's just waiting for all the bits and pieces to get wired up. Don't worry, I tested. And now everything is working. So all I did was I did a refresh on my browser. I waited about another minute. Again, just time for that instance to reboot, for the agent inside to try to connect to Session Manager. And it was able to make its connection through that VPC endpoint. Let's double check everything by hitting connect. And we are logged in, and I can just see everything in that directory. All right, so let's unwind to this a little bit and see what we actually did. So if I go into VPCs, and I don't think it shows up on the resource map. Let me hit a refresh here to see if that actually would pop up. Go back to the resource map. So you see it doesn't show on the resource map, and if I go to click on my subnet, I won't see anything different because this is not IP-based routing. So by clicking on that route table, you can see local traffic being routed locally. The magic is occurring here on the endpoints. These three endpoints enable the three different services. And let me zoom in on those so you can see those right here. SSM, SSM messages, and EC2 messages. And the routing is happening magically through the DNS that's configured for this, so that when I go to ssm.amazonaws.com, that is magically routing it to my VPC endpoint. And if I look down here, you can see that these are interface endpoints, and I can actually pull up the DNS names that have been associated with those. And if you poke around a little bit, you can probably find those IP addresses. All right. So as with everything, these wouldn't cost you a lot, but it will cost you some money. So let's go ahead and tear that down. So we are connected here. I'm going to close that connection, and I'm going to go here and go to Actions and delete VPC endpoints. And you have to type in delete. Now, I can't tear down my CloudFormation template until these are done deleting. It can take about 3 to 5 minutes, so I'll do another pause. Took just a few minutes there, and all those endpoints are deleted. Now, to finish our cleanup, we'll go back to CloudFormation, click on the little button, and click delete. Now, this would fail if I did not delete the endpoints first, because those would still be tied in the VPC, and then you couldn't delete the VPC. All right. So we went through this really quickly, but it's a very cool lab because we were able to connect over a terminal shell through the portal, or sorry, through the console to a fully private instance in a fully private subnet that had no internet access in or out, and everything was done back on Amazon's backbone network. VPC endpoints are really great for all of this. You do want to be a little bit smart about deploying them because the cost can add up over time. But this is one of my favorite cloud capabilities. Anywhere in the world, I can now connect to these instances with strong authentication and then drop right in, even if it's on a fully private subnet with no internet access. That's it. I hope you had as much fun with this one as I did, and we'll see you next week.